Okay, now let's try computing, writing a Turing machine to compute the decrement function, which is going to be very similar to before. So now instead of increasing a number on the tape by 1, we're going to be decreasing a number by 1 on the tape. And because we can't really handle negative numbers, or at least we haven't encoded a way to do so, if the number is 0, we'll leave it as a 0. Otherwise, if it's positive, we'll decrement it by 1. So our algorithm to do so is starting from the right-hand side of the number. If it's a 0, flip it to the 1, move to the left and repeat. Else if it's a 1, flip it to a 0 and halt. And also if it's a blank, halt. So for example, if I have the number 1, 1, 0, 1, 1. So from the right-hand side, if a 0, flip to a 1, move to the left. If, whoops, let me pick a better example that actually works. There we go. Alright, so I want to decrement this number by 1, so I have to do carryover, which is fine. This algorithm accounts for that. So starting from the right, if it's a 0, flip it to a 1, move left. 0, flip it to a 1, move left. 0, flip it to a 1, move left. 1, flip it to a 0, and then halt. So that means this 1 stays the same. So we had 1, 1, 0, 1, 1. Sorry. 1, 1, 0, 0, 0. And that became 1, 0, 1, 1, 1, which is indeed 1 smaller than what we started with. Okay? Looks like the right algorithm, so let's implement it. Thankfully not too hard. So the first thing we have to do is we have to rewind the tape all the way to the right. So if I see 0s, put them back. If I see 1s, put them back. If I see a blank, put the blank back and step to the left. So therefore I'm at the left of the string. If I see a 0, I flip it to a 1. I move left, I try again. If I see a 1, flip it to a 0, do nothing, and then halt. And if I see a blank, put the blank back and then stay. So 0, 0, 0, 0 will be decremented to 0, 0, 0, 0. So decrement does nothing on any string equivalent to any string that has, representing a number in binary, representing the number 0. So that's how we can do decrement. So I've got increment, and we've got decrement. We can put these two things together and get addition. So first off, we can black box this thing away by removing the state H. So we can put just these two parts in a box. 0, 0, R, 1, 1, R, blank, blank, L. Read a 0, write a 1, move left. Read a blank, write a blank, move S. Read a 1, move a 0, stay. And then we can sort of put that in a box. I'm going to call this the decrement subroutine. And this can now be a part of a larger Turing machine, this little box here. Okay? So I've got increment, that's what we did last time. I've got decrement. How can I put these two things together to make addition? Well, quite easily. If I have x and y on the tape, if I want to compute x plus y, what I can do is I can increment one number, decrement the other number, and continue to repeat until one of the numbers is 0. So, for example, I'm going to use inc of x to represent the increment function, and dec of x to represent the decrement function. Increment, decrement. Because we know how to write both of those machines. So now we can write addition. So we can define it sort of recursively. So x plus 0 defined to be x, and then x plus y will be increment x plus decrement y. So this will get bigger and bigger, and this will get smaller and smaller. Eventually this term is 0 and we return the first argument. So that's our sort of rough sketch on how we're going to do this. Okay, so if we want to do this on a Turing machine, we're going to have two inputs, and we'll request that the two inputs are separated by some sort of hash character. So the input is going to be some number, B1, da 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 da. So some number of bits, and then a hash, and then some other number of bits, and the output should be a single number. So some new collection of bits, D1 through DK, such that if you interpret this as a number in binary, it's equal to the sum of the two inputs. Now that's where we're sort of going with this. So our rough sort of sketch is going to be check if one of the numbers is 0. So maybe we'll increment b, because when we want to increment a number, we grow to the left. And when we decrement a number, we shrink. So I got my number here, b. Every time I add to it, it's going to get one bigger, and it might, grow further off to the left-hand side. And then I decrement c. And then when c is 0, then I wipe out c, I wipe out the hash, and I leave just b on the tape, right? So that's the rough sort of algorithm we're doing here. Have a go at designing this machine, and then we'll go through the solution in the next video.